run inference on. So here we see now the embedding space, if it was the real data that was allowed, how it should look. And I also did another thing. I calculated for each synthetic sample, I calculated the distance to each real sample in the real embedding space. So so I had a score per synthetic sample on how far away it was from the closest real sample.
Okay.
Does that make sense?
Yeah.
Then I can filter on that, and we can see live how that changes the picture. And you see the class imbalance you get at the top now. Still, we have a lot of synthetic samples used, but now it resembles more if I was only looking at the real data.
Yeah.
So I kind of removed all those synthetic samples. This is what I'm doing here.
Oh, that's exactly what I was referring in the previous slides, right? When not slide, previous part of the demo, where I said that there was part of this thing which was you could actually do a classification to tell the synthetic and real apart. What you're doing here is you're saying that, okay, we'll remove all the synthetic data which are far away from the real data and only keep the synthetic data which is in that cluster. They're very, very. I really like how you thought about it. It's very, very smart.
Exactly. So I retrained the model with only using training only on the real data, capture embeddings again on everything, and then calculate the distance from the synthetic samples to the real, and then filter on that. So what I did now was I reduced it to 75. I removed 75% of the synthetic data that was originally created. So a much smaller data set. And then for each of these classes, based on the balance, I selected all the samples and set the weight accordingly so that I got a balanced distribution of the different classes. And the dataset integration into PyTorch now takes that into account and upsamples the samples for you so that you get a balance. Of course, the best thing would be to add more synthetic data within the region, but I couldn't do that. So that was the second best thing. And what was interesting was that after that training run, I managed it. The accuracy went from 97 to 98% on the blind test data.
Wow.
With 75% less data.
With 75% less data, which is fascinating. First of all, that 1%, it looks like, oh, it's just 1%, but at that level, when you're at 97%, getting to 98%, it's massive, right? It's not like
33% reduction in error.
Yeah, exactly, right. So it is a very nice result with just doing data analysis, right? I like to say that data is like, a lot of people don't want to do this, and I have seen so many good people who produce very good results. They spend so much time with their data. It's a gold mine which people, amateurs usually ignore, but the really smart people, they spend a lot of time with the data.
Yeah, it's the most effective way to get a better model. The inconsistency or balance, or often you need to provide an unbalanced data set to a model to get good results. It's always not intuitive.
Right.
So, all right. So this was leading up to the Kaggle competition where I did something similar, but focus here was to delete the right data to improve the model. So let me go back to the PowerPoint, and I'll talk a little bit about what the challenge was. So this was put out, I think, 3 months ago, and it's from the company Nexar, that is a dashcam AI company. And they had 60 million hours of recorded videos, and they labeled 4,500 or 5,700 of those videos with 40-second videos where half of them had an alert when there is a possible dangerous situation. And also the second tag in the video was when a crash or near crash happened. So there was 2 labels per video. And the task was to take 3,000 training samples, 3,000 videos, and train a model to predict when a crash happened. Or when an alert should go off, actually. That was the task. So I never worked with video before. It's mostly been segmentation and object detection and classification and so on in computer vision. So I thought this was an interesting task, and also see how 3LC could be used for this. So I'll show you a tiny bit of code first, and then go live on what I did with the data. So first thing I had to do was to pre-process the videos. And of course, I used OpenCV for that.
That's great.
Yeah. And so I wrote out frames for every single video. Next, I registered that data as a 3LC table. And it's very easy. You just define a schema. And I wanted to keep which original video ID it was, which frame it was, time to alert and time to event, which was the 2 labels. And I also wanted to tag all frames that was in the zone from alert to event, as that an event is about to occur. And I also wanted to be able to filter if the video at all had a crash in it. Half of them didn't. So with that, I wrote out a 3LC table, so I could now start analyze the data in the dashboard and do data edits and so on. I decided to focus on the data side, so I just from the beginning, I picked a built-in torch vision model, and didn't change it since. I changed the output to be a single value, whether a crash occurs or not. And that was all I did with this
So
model.
this is a standard model from Torch Vision. The only thing you have changed is the last classifier, the number of classes.
Yes, exactly. So this was all I did, and of course I did some standard augmentation, and so on, but nothing. And I didn't experiment with this. I kept it from like this from the beginning. I'm sure there could have done some work there as well, but that was not the point of what I tried to prove. And
so these are minor rotations and things like that, right?
Rotation, resize, brightness, contrast, saturation, and these things.
Yeah.
For the training itself, after a while, I decided to use a random sampler, but I didn't want to train on the 2 million images each epoch, because that would take 2 days. So I trained only on 6,000 samples, random sampled out of the samples, whatever, how many samples I had in the data set. Also important is that this network takes 16 frames in. So even though each training sample was a single frame, I loaded the previous, 16 frames times 4. So I did -4, -8. So I loaded 16 frames in the data loader for each image. So I fed the model 16 and 16 frames for each training sample. All right, let's go to see how this looks. And should have it.
This is Phil butting in here real quick to let everybody know we are now live on all of the YouTubes and LinkedIns and stuff. Sorry about the late start on those platforms, but thanks so much for joining us.
All right. Welcome, everybody.
All right. So here again, we see that since I now have a different schema, I have all the things I registered automatically pops up in the UI, so I can filter and plot on that. So of course, first thing we can plot is the images. I have 1.1 million here. It was originally 2, but I cut all the images when registering them after the crash, because then it's not. I found it to be not very useful information with people coming out of cars and yelling and these things. So I thought it was wise to just not have that in the dataset from the get-go. Next, we can plot, for example, which video ID it is, and which frame number in that ID, and whether the event occurs. And now we get an interesting plot, because now we have which video horizontally and which frame number vertically. So we can now easily see where it goes to green. That's where an alert starts, and the crash is at that frame at the very end here, or near accident. That was very blurry image. Yeah, this is right before a crash, most likely. Yeah, you can see that now it is crashing. So this was a good way to study it. I took the first training run. I also captured metrics like embeddings again, and I also captured the probability of a crash. And we can plot, I also filtered that on whether that was very high, so I get a Boolean. We can also plot that again with this one to see what the predictions are like. And they are really, really similar, but there will be differences. And here we can see, for example, that there is something that is predicted, but not a crash. And it's not labeled. So on the left side, we have the ground truth. On the right, we have the predictions. And in my mind, this car is moving really fast and then slamming the brakes.
Right.
I actually think there should be a label here, but there's no event occurs, so no time to alert or time to event. So I went through the data set and found lots of cases like this. And I didn't relabel the data. What I actually did was to then take this video. In this case, it's video 01089, and filter that in. I took the lasso tool again, selected the region before after, and I set the weight to 0 on all those samples. And then I can also filter on the weight so we don't see weight 0. And lock that. And then I did, we could go back and look at all the videos. So I kind of removed.
So remove the, okay.
I removed the uncertainty.
Okay. Okay. And the reason you did not, would you have, let's say you had the, people labeling for you, would you have actually asked them to relabel this data? Or
I would relabel it here. Right here, I would click on the frame and said, here alert is this, and I would just relabel it here. I could select, select that region and just hit event occurs, and I would have relabeled it instead.
Got it. So the reason you chose to remove it versus relabel it was that an arbitrary choice, or there was?
No, I think it's a little bit dangerous to relabel when you don't know how the other data is labeled, like the instructions and guides, because it will guaranteed be inconsistent.
Yeah,
and which I also will come back to in some other things here. I'll do another interesting plot. If we take the video ID and the frame number, and on the third axis, we will plot when probability is higher than 0.95.
Yeah.
And we also will plot it with event occurs as color. So now we get a nice separation where we can clearly, because sometimes it's hard to see things in 2D when you want to plot 4 dimensions.
Right.
And here we separated out where there is a high probability, but it's colored by whether it's correct or not.
Right.
And what I found is that the model has a tendency to predict, these are predictions of the model that it predicts an alert will happen before the label arrives.
Okay.
So the model seems like it was able to predict the accident earlier.
Yeah.
Than when the alert was labeled. However, it can also be just because the frames are similar and it's overfitting.
Okay, yes.
So I did another approach here, because labeling this series of data must be really hard. Like from one frame, it goes from no alert to a second frame, it goes to alert, right? I would say that is a really hard task. So what I did then was to select all the videos that has an event. On the left side, I select those. It's still all this, of course. And then I went from time to alert minus 0.1 second to 0.1 second. Let's do that. So I filtered in that confusion zone. And I actually also deleted that from the training data, because I guess the labelers aren't 100% correct.
Yeah, of course. That happens so many times.
So instead of showing incorrect data, I actually decided to delete that as well.
Okay.
So that takes away those 10 frames or 8 frames around the label, because there's a lot before that is really that is more certain is correct labeled, and of course after it, you also have now frames that are more certain are correctly labeled.
One question I have is, when you're using this tool, let's say you're deleting data and you're changing things, right? Of course, the data is there; it's not deleted. It's you're just setting the weights to 0.
It's nothing. It's like Git. Every revision is just a revision of the changes, and you load the last revision in the training, and then all changes goes into effect.
Right. But is there a track of things that you did?
Yes, like this. So you have a full data set history of the revisions and so on.
Oh, it's just like Git. Okay, that's very nice.
All right, so that was that, and then we can go to the embedding space.
One last question about the tool. So it looks like you are running it. Is this a desktop? I'm unable to say whether this is a desktop tool or is it a.
It's a web browser based.
Okay, so yeah, go ahead. Sorry.
Yeah, and you start a local service.
Yeah.
This is not a SaaS, so you just start a local service that serves the data wherever you store it, cloud or laptop, and to the dashboard. So no data leaves your premises.
Got it. So basically, on your laptop, the browser opens up. There's a local address and which you are working on. So everything is browser based, but it is local to your machine.
Yes, or you can host the service in the cloud, so many people can share projects and whatnot, and you have your browser locally.
So you guys provide a Docker container, or how does it work?
You pip install and start the service wherever. You can, of course, start it in a Docker.
Yeah. Okay. Sounds good.
There's on the docs.3lc.ai, there is a section about how to deploy it in different environments.
All right. Sounds good.
All right, so back to embeddings like the previous one. And what's interesting here is that if you look at the embedding map and plot it together with the loss, we see that there is one region, or actually we can do with where there are probabilities of crash. We see that there is one region, most of the data is not relevant at all. Right? It's only in this region here there's a high probability, and also the error, if we look at that, it is highly concentrated only in this region. And we can do a 3D plot with this, where we can plot with event probes, and we can do the loss along let's do loss along the third axis and then the event probes. So give you a clearer view of what goes on here. And of course, this is the really important data to train on. But how do you decimate this data then if you want to train on less data? We have all these samples around here that is always 100% correctly labeled.
Yeah.
And we don't want to train on them. So one strategy, what we can do is to, let me close this and just
So Paul, just to for the audience, we don't want to use easy examples, right? So when you are training an AI model, right, there are a few things important, right? One is that there needs to be variance in the data, right? The variety in the data is good, and then you need to look for hard examples, the places where the model is failing, right? So you can keep putting easy examples and the model performance is not going to improve anymore because it's already doing a very good job on easy examples. You have to select hard examples and focus on that much more than easy examples.
Exactly. So training on a million images around in this area, it just doesn't make sense, right?
Right, and people may be thinking that, oh, there is no harm in training with easy examples. There is harm because you have limited computational resources, right? You don't want to wait days.
Yeah.
It's still going to pass those easy examples through the network, right? So there is harm, right, on easy examples. More data can be harmful, and sometimes even the accuracy can be sacrificed because you're training on very easy examples.
Absolutely.
Hey, Paul, can you do us a favor and remind folks the name of this awesome visualization tool?
3LC. 3LC, and you find more information on 3lc.ai.
Three lines of code. Yeah.
Thank you.
And so here I decimated the data set, and I could, of course, now train on only that, just save this revision and train that, but that would be very bad in the importance section. So what we can do in 3LC is to actually take the embedding and the loss, and, oh, I cannot see myself. Let's see there. And calculate something called traversal index on these two properties together. And what's interesting now is if I clear this filter I set here, and we decimate on this one instead. Let's say we only want to train on 20,000 samples. You see that now you get a distribution of the data that is evenly spread where data is not that important, but you get more and more samples where it matters, where the model struggles.
Very nice.
So this was the first thing I tried, and that boomed the accuracy from when I started from 71% up to 82% accuracy. And training time went down. It converged in like 6-7 epochs, 15 minutes of training on all the videos.
Huge numbers.
Right?
Yeah, and people don't realize that every time you get more than 5%, in fact, every time you get more than 1% increase in accuracy, you can almost tell that the data has been analyzed, not the model. You can keep changing the model architecture and get zero results, right? You will maybe get half a percentage point, right, increase. But this kind of analysis is what gives you 5%, 10% improvements, I love it.
Absolutely. So to cut it short, what I didn't end up using this approach actually. I ended up weighting data intelligently based on whether it was in the zone of soon to crash. I weighted all videos that had crash in them more than videos that didn't have crash, because I was afraid of the model would overfit and learn from just a scenic view of the video, since it was the same. And I also weighted up I actually deleted the last 0.25 seconds before the crash also, because the task was to learn the alert, and things got more and more chaotic close to the crash. So I tried a ton of different strategies, and sometimes I found something that really worked, and I slowly climbed from 82 to 89% accuracy on this challenge. So that was experimentation.
What was the second person? What was the second best in the competition?
So the private leaderboard that I didn't see before I knew I won, I got at 87.2, and the second was 86.4, and the third was 85.5. Okay. And congrats to those. It was really, really close race, and it was very different approaches. The second place used a really large model, And I really love the third place, Max Swager's approach, because he also wanted to make it simple. So he was inspired by the Netherlands driving school, where you have to look at 2 pictures and estimate if it's dangerous or not.
Oh, nice.
So he only used 2 images per training sample.
Oh, wow.
But he calculated optical flow and all these other methods. I think the second place also did. And yeah.
So that's another thing, right? Sometimes I feel that people who have an edge in developing models, etc., right? They first of all, they spend a lot of time with data, but they also sometimes combine classical computer vision methods like optical flow and to improve results, right? So when you have this bag of tools with you, it actually really helps to figure out. And also all the various things that you're doing, right? It requires you to have some understanding of how data works, right? How the training works, how to think about the data, instead of just, oh, I just used a YOLO model and here's the output and it did not work out. I used YOLO V11 instead of YOLO V8, right?
Tiny little bit better.
Yeah, only tiny improvement, if that, right?
Yeah.
So this is the right approach. The data-centric approach is the right approach to get very high quality models. And I had, there was many years back, we at OpenCV, we had developed a facial landmark detector. We had trained a facial landmark detector, the accuracy was not as, it was trained by an intern, and the accuracy was not good as another model which was trained, same paper. We had implemented the same paper, and I personally, actually, I verified the code, that the code is following what the paper says, and yet the accuracy of our model was way less than the accuracy of DLib, right?
Exactly.
So I happened to talk to the author of DLib, and I asked him, what did you do, right? Why is our intern not able to get the results? He said, I sat down for 3 days with my headphones on, and I looked at every single point, everything that, so there are like 86 or some points on the face, right, which have been manually labeled. He went and relabeled. He verified each and every image, right? And there were a couple of thousand images. And I said, you did that? He said, yeah, it took only 3 days, right? And that's the attitude people should have, right? That it took only 3 days. You sit for 24 hours, right? 8 times 3 with your headphones on. And that's what he did. Every little, and he used all these, he did not do it completely, mindlessly. He had his mechanisms of finding which points are likely wrong, right? And he had some, he would do this, he would train a model, he would find negative examples, and all these things he would do.
Add this, yeah.
So it was a data game, right? The exact same algorithm was implemented, and his data was much more refined than ours.
It's always a data game, and that is what we see with the users of our tools, that they increase their accuracy, but it's by training the model, understand how the model reacts to the data, take changes accordingly. Very often you find that the labels are perfectly labeled, but it might not be what the model needs to do its job, right? So you have to find that out. Satya, how are we on time? I had one more.
We got plenty of time. We can go over a bit here today since we had some technical issues. Let me pop myself back in the video here. So now, in fact, Paul, is a good time. We're going to do our trivia giveaway. So we'll give you a breather for a few minutes here. But before we do that giveaway, I'm going to remind people how this works. I have made up a trivia question during this show for y'all. And the first person to answer that trivia question correctly, either in the Zoom chat with messages set to everyone, or on LinkedIn or YouTube, we're looking at, or Twitch, LinkedIn, YouTube, Twitch, or Zoom. The first person to answer it correctly in the chat wins a free OpenCV University course. You can learn what courses are on offer by going to opencv.org/university. In fact, let's go to OpenCV University now. Doc, can you tell us a little bit about OpenCVU and why it's important and useful for people?
Yeah, so OpenCV University is a collection of all OpenCV. We have a collection of courses that allow you to become from beginner, right? All we want is you need to have a basic understanding of any programming language, and
right.
from there we can transform your career.
Look, there's two Satyas on the screen right now.
That's great. And
Let's scroll down a bit here.
and yeah, so basically it's a collection of courses that will take you from beginners to mastery, right? And out of these two courses, we have a bundle called Computer Vision and Deep Learning Master Program. It has the collection of all the courses, and that is also the most popular bundle. Among these courses, there are two important courses. One is Fundamentals of Computer Vision and Image Processing, and one of the deep learning courses, right? So we honestly think, right, it takes some amount of time, about 7 to 9 months. But if you are able to complete these courses and get above 90%, your chances of getting a job in the computer vision and AI marketplace, it's enormous, right? It gives you a very big edge. So try it out and see if you like the courses. And we also have a 30 days, no questions asked, money back guarantee. Please check it out. And it also supports this kind of work we do for free. It supports the library, which is, it has been completely free for 25 years now. So
That's right.
Yeah. So it's a
all right,
for
folks.
everybody.
Yes, thanks so much to OpenCV University. I think it's one of the best things we do here at OpenCV. And I'm looking forward to giving away a free course to you out there in the audience. So let me just hide Satya's video here. There we go. Yes, today's episode brought to you by OpenCVU. I have a feeling folks are going to get this one. Sometimes y'all get in my head, and it's difficult to outwit you, but we're going to try here. So answer in the chat. If you have won in the last couple of months, please don't answer and give someone else a chance to win that sweet OpenCV course action. CVPR is coming up soon. OpenCV will be there. We've talked a bit about OpenCV today because this is OpenCV Live. Longtime viewers, however, will know what year and month was the first version of OpenCV released. What year and what month was the first OpenCV release made? Year and month. Oh, we're getting close. A couple folks in Zoom are close, but you're not quite there yet. Not quite, folks. No, it is not 2005. No, it is not.
2005, it won the DARPA Grand Challenge.
That's right. Yes, but some folks are getting the year correctly, but what month and year? Month and year. Oh, there we go. Up in the Zoom chat, we've got OJ Singh. OJ Singh on Zoom was the first one to correctly guess June of 2000. Congratulations, OJ. Please send exactly one email to phil@opencv.org, and we will ensure that you get the course you want. Of course, you can go and find out what are on offer by going to opencv.org/university. I'll even bring the QR code back up there. Scan that QR code and hit up the website. OJ, pick a course, send it to me, phil@opencv.org. Congratulations. We've also got we've also got OpenCV merchandise here, folks. You can pick up t-shirts, pins, buttons, pet bandanas, stuff like that. We will have some freebie stickers and buttons available at CVPR in Nashville this year, but they're not quite as nice as the ones that you have to pay for. That's all I'll say about that. Hey, we're a nonprofit organization, folks. I'm going to go ahead and bring back Paul and Satya here so we can chit chat some more. But I'm going to remind the folks while we're here that OpenCV is a nonprofit organization that puts out free software for you with a very permissive license, and as such, we depend on the support of friends and companies such as the big OpenCV sponsors, which I'm going to pull up on the screen right here now, just so we can thank them all. We really do appreciate our sponsors. We could not do it without them. We should have the screen share up. Yeah, there we go. A big shout out to our members and partners, as you can see right here on the screen. We really do appreciate all the heavy hitters there and the small fries giving us that money. We're going to do some updates to the website here soon to make sure that our partners and members get a little bit more space. But there's other ways you can help OpenCV. You can sponsor us on GitHub. That's github.com/sponsors/OpenCV. We've got 13 sponsors currently. I'm going to give them their flowers right now. Shout out to Live Peer. Shout out to iPop, our friends at iPop. Hey, they were just on the show. I love it. Show to donor pipeline. That's what we got here. DJ Greenwood. We've got Redis Laboratories. We've got Tala Hussein. We've got the homies at RoboFlow. We've got Alex Ismailov. We've got Comet ML. We've got Jonas Heinle. We've got Nick Libertini, Blue Jay, Jesus Anaya, and Victor V. Thank you all for donating. That's github.com/sponsors/OpenCV. And on the merchandise shop, and I was just talking about, we got 20% off everything right now. Get the iconic import CV2 command on a hat, a hoodie, or a shirt. You can also get the OpenCV logo on those various items of apparel and the I Love OpenCV shirt in English, Espanol, and simplified Chinese. Thanks for your support, everybody out there who checks out the merch and buys stuff. It really does help. Also, OpenCV's got a workshop at CVPR this year. We are really looking forward to it. It is June 12th, the Perception for Industrial Robotics Automation workshop, where we'll be talking about the winners of the Perception Challenge for bin picking, which we're going to be announcing once the robot has its way with these submissions. So we'll post some videos and let you all know what's going on with that very soon. OpenCV will also be, I forgot about this one. We've got too much going on, boss.
Yeah.
OpenCV will also be at Open Sauce this year. With our friends at Ross and I think Hackster as well. So we're gonna have a little space over at Open Sauce in Daly City I believe it's at the Cow Palace again, which is it doesn't mean anything to anybody that doesn't live in the Bay Area. But shout out to the Bay Area homies who know and love the Cow Palace. So we've got some questions here. Do you want to let's go back to presentation for a bit, Paul, and then will you have some time for questions?
Yeah.
Okay, fantastic. So I'm going to go ahead and drop off my video here, and we'll turn your screen share back on.
All right.
Okay, where's the screen share? There's the screen share. All right, it should be good.
All right, so we're gonna do a 180 degrees swap to instead of deleting data or and so on, we actually are gonna add data and use the same model feedback to do that. And there is a lot of research and papers around how you can auto-label and use zero-shot models and so on to label. But in my experience, it's not enough to just do that and hope for the best or filter on confidence or these things. You need more insight and actually a human in the loop, but a very effective human in the loop. So I will show you how we used model feedback to go from 300 instance segmentation labels to 23,000 in a single day. And it was my colleague, Frederick Melby, that did this. So let me see, where is my screen? All right, so what we did here, we had a data set of 40,000 images and 300 were labeled. This is from a marine.
So only 300 were labeled?
Only 3,000? Yes. Yeah, okay. Only 300 are labeled at this stage.
Okay.
So we ran YOLO 11 with the instance segmentation and trained on only those 3. However, we had all 40,000 in data set, but if you see the weight column, most of these are 0.
Yeah.
Most of them are weight 0. So that means that they are not taken into account on the training, but we get the predictions. So what we can do now is we can filter in all those weight 0 images, which is still 39,000 something images that are not trained on. But we do have predictions on those. Right. So we can run one of the workflows. Let's do the instance missing label workflow. It takes you through what it does so you can learn the tool.
So these are pre-canned workflows that you have produced. Which
yes, we have a lot of these, and they will also show up based on what type of properties you have, metrics you have recorded.
Okay.
But you can also always set this up manually if you and as well. So the tool itself is very flexible. In mechanisms are simple. You can filter either on slider bars or labels and so on. On the left side, any property can be filtered, any property can be selected, and anything can be plotted against each other.
Up to 3.
And then you can select in the screen and change your data. So what we now are looking at is the unlabeled image to the left and the prediction to the right, segmentation prediction. And of course, we can browse through all these samples, and things look good. We could theoretically now have added 5,000 or 6,000 new instance segmentation and then trained on those. But it's a little bit risky, and I will show you why. If we go to the predictions and we derive, let's say we want to derive the pixel counts. So now we have a new category called pixel counts per segmentation. And if you do a plot of that, a logarithmic plot, again, explains what it does. So these are the different pixel sizes on the predictions. And if you go to these large ones, we see that, oh, that is not good. That is the underside of a boat, right? So that's the risk when you only train on 300 images.
Right.
So you definitely don't want to add those. You want to start adding all those that are small, for example. But some of the fish or some of the things are always up at the top as well, top of the image. So really, we don't want to start with adding instances that touch the top of the picture. So what we can do then is to go and say that on these predictions, we derive this min ys, and we get a new column that we now can look at. So where did it go? Y-min, we can select that. So if I now filter on, take away all zeros from that filter on left side, so no prediction has to have a min y lower than 50.
Okay.
Then I suddenly can add the large fish as well, automatically.
Yeah.
So I kind of hone in on all the parameters that are making possible bad predictions, and then I add all those selected based. So still 5,400, but now much more high quality. We also captured embeddings here. I did not have them in this run. And we also saw in the embedding space that there was a pattern to the lower right that was more fishy than everything up to the left. So we added only in that region.
Okay.
And then we add, let's say, 1,000 new labels, high quality ones. Takes maybe 15 minutes. Train again. And then we got even better predictions. And then we can also replace eventual bad ones. And we iterated, took 7 hours to get to 23,000 really high quality labels. Starting from 300.
Wow.
So I think that is quite powerful, and we see that more and more.
And just to give you an idea, for this to be done manually, it would have taken 15 days, a team of 2-3 people, and maybe even more, right? And they would have hated you.
Yeah, absolutely. And you can also edit if there is something wrong in this. Now I added a mask, right? And I can, of course, edit it also. So you are free to label in this tool as well. Yeah. And when you're done, you just write a file name, whether it goes to Object Store or to your local drive. And that is now a revision that you restart your training, and that is taken into account. So it's very quick to iterate on the iterations. Sorry, there is someone blowing.
Oh, good. The leaf blower's here.
Leaf our outside window today. That is typical.
That's so funny. No, I mean it happens to me here as well, but I'm just high enough off the ground that you can't hear it in my audio.
And to just end this session, I wanted to show you something about the Cocoa dataset. And Satya, I think most people or many people are familiar with the full Cocoa dataset.
Yeah. People don't know how messy the data set is.
Exactly. So this is the dataset that the YOLO foundational models that everybody is using is trained on. And of course, we can do interesting things to filter in all the bounding boxes or images where there's a person and a bird and a cow in the same image. But let's do something else. Here we actually captured not embeddings per image. We captured it per single bounding box from the training. Mm-hmm. So that's almost 1 million bounding boxes here. And if you now start...
Such a cool visualization.
Yeah.
If you filter on this, we will find very many interesting things. We'll see that there is this peculiar little kind of tip.
So here we are looking at a particular class of these points, or
yes. Now I selected person to the left, so now we are only looking at the person embeddings.
Okay.
And if I now select this region here, we will see that these are not very good labels of persons.
Right.
These are quite horrible.
Also, I wonder if they got the express written consent of Major League Baseball.
And if you now go take car, we will have the cars within the same region.
Yeah.
And we see the same.
Yeah.
These are not very good. Also, in this data set, if I do the same as before, use the model feedback to do the find missing label workflows. Let's see where they are. Inaccurate labels, inaccurate missing labels. Yes, let's skip the steps so that we have there. We will now find a lot of potential missing labels in this data set. So, well, that's a share behind there. This is a banana. It was not labeled.
Right.
So, and we find almost 11,000 of these very easily. Potted plant. And of course, if you browse through and 19 out of 20 is good, I would say just to accept selected predictions for all rows you now filtered in. That would be 11,000 new bounding boxes.
Wow.
So it's a very good model to a way of train the model, find what is missing or where there's potential errors and which data didn't help the training, and change your data and change it quickly and train again. Experiment with it.
That's amazing.
Extremely cool stuff.
Yeah, so this kind of missing labels can completely screw up your training accuracy, right? Because these can be part of the negative set, and all these things can affect.
Yeah, it's always an issue when you're fine-tuning a model that your label set is good.
Yeah.
And very often it's not only that it needs to be good, but it needs to be the right size of the bounding boxes. It needs to be the right classes you're labeled. If you label damage on something, maybe there's things that look like damage. You will get feedback from the model that it has a lot of false positive on something that look like damage but isn't. Maybe you need to label that too. Right, and these are things you need to do to fine-tune a model to do what you want.
That's great. So tell me a little bit about the tool. You mentioned before we started that this is free for individuals as well as for research purpose, right?
Yes, absolutely. So it is a Python library. It is you host the service that feeds the dashboard. So there's no data leakage. You integrate it with your training script in hopefully 3 lines of code. If you use Ultralytics YOLO or Detectron or other famous frameworks, then we have integrations. So then you don't need to do anything other than install it.
So okay. So but you still need to add a couple of lines in your training script, right?
Yeah, you need to add that you use the TLC package together with YOLO, for example.
Got it. Okay, yeah. That's awesome.
Yeah, pretty awesome tool. We've got a couple of questions here from the audience. So if you've got a few minutes to answer them here, let's Yeah, thanks again for sticking with us, folks. We had a little, some technical hiccups this morning on YouTube and LinkedIn, but we sorted them out. I have battled the web browser, and once again, I have emerged victorious. And we will bring up here. Here's just a reminder: we're taking your questions. Post them in the chat wherever you are, and we will bring them up on screen. We've got one earlier from Samuel Lee here. This one's for Paul. Paul, do you think that the current vanilla models provided out of the box by various packages are more than enough to handle most competition level challenges? Contentious question.
It is a contentious question because, of course, you would have to fine tune those models on the data in the challenge. But I would say at least you should start there and see how far you can get with the data first, because that can improve the model much more than just changing to a different architecture.
Yeah, I mean, one other way to think about it is that in a competition, you have a limited time, right? Are you going to experiment with model architectures which have very low probability of success, or would you like to experiment with the data which has very high? There's a video by Dr. Andrew Ng on data-centric approach where he shows various examples in which they tried, a model-centric approach versus a data-centric approach, and model-centric approach usually was the same or half a percentage point, and most of the gains were made because of the data-centric approach.
Absolutely, it's so powerful, but of course, changing data has been very, very tedious. Right? It's if you ask a data scientist to change all the data, that's like headache, and that's why we built the tool. So it should be very, very easy to do these operations and restart training.
Right, and with tools like 3LC, the headache part goes away, right? I mean, there is no excuse to say that, oh, it's not tedious. It's in fact fun looking at the way you have presented it. It is fun to look at that data and see. It's almost like you're going in like a detective and doing that work.
Exactly.
Yes, we've got another one here. Very important question for Paul. What's your cat's name?
That's Zoe. She's my boss. Zoe.
Hello, Zoe. New star of the channel. Everybody loves Zoe. We had quite a few people asking this one here. Can someone tell me the name of the tool? It's 3LC dot AI. In fact, I'm going to bring up the QR code here. You can just scan that and go to the web page. I'm looking. We've got another couple questions. I think we have two more. Time for two more. Does that sound good, everybody?
Yeah.
Okay. Not Nosley. Do you have any code available on GitHub for any of this stuff?
Yes, so we do have, first off, in the documentation on docs.3lc AI, we have a lot of examples, but we also have a GitHub with a lot more tutorials and examples and using SAM and different integrations and how to go fully manual and if you just want to register data and metrics fully on your own, how to do these things more advanced.
That's great.
So it's github.com 3lc-AI.
Oh, that's great. You have an invitation for a workshop.
You ever been to Hawaii, Paul?
We are planning on going there, actually. We are planning on having a booth. We haven't signed up yet. The deadline is not there yet. We are going to CVPR. So you'll find us at CVPR. We have a booth there.
Okay, yeah, it looks like Ali's really interested. We'll do an email intro between the two of you. Ali, go ahead and send a DM to the YouTube channel, and we'll make a contact. Yeah, we're wheeling and dealing here, folks. Love to see it. Love to see it. There's another. Let me find it here. It's tough to. So we had another question here from Zoom. which was for Satya, not specifically about this, but about OpenCV University.
Yep.
This Kamal is this person's name. They started OpenCV courses. The OpenCV, getting started with OpenCV Python, I believe, was the course they were talking about. But they feel like they're struggling with the Python part. Do you have any advice for people that are maybe newer to writing Python, especially about maybe some resources that can help them kind of skill up to the level of the course?
Right. So the best resources I've been using. In fact, I recently, my son, 9-year-old, he participated in Science B, and he went to the nationals and then won the 4th place in the country. Right. So and we did not use any any other resource other than ChatGPT. Right. Yeah. So ChatGPT and YouTube. I'm not even kidding. So you can actually ask ChatGPT to create this, and also it will give you little programming assignments that, okay, if you have understood this concept, right? So ask it to create like, okay, I want to learn Python. Tell me concept by concept what I need to learn, right? So once you do this, then you ask it, okay, I want to, tell me what code to write, give me some tests, etc. So I think that level would really help you, where you hone down on specific things, right? And gradually improve upon your skills. And as long as, if you did not get a concept, you can keep asking it to give you little programming assignments, and it will give you those programming assignments that you can try and cut paste, and also get feedback for your code.
Yeah.
Right.
Yeah, I've actually heard of people doing this, like not even for code, but for like, say, learning to play the guitar, for example. Like make a lesson plan for 12 weeks that I can spend 15 minutes a day, that sort of stuff. I can see the value in that. Obviously, it'd be better if you talk to a person, but there's not that many people. Not everybody knows a guitar player.
Right. The other thing is, I'll give you another example. We recently did there's this exam in India called IIT JEE, and this is taken by like the JEE exam, joint entrance exam. It is considered one of the toughest exams in the world, because about 1.5 million people take this exam, and about 17,500 or so are selected. Right. So
wow. Okay.
yeah, so it is extremely tough. And we basically took screenshots of this exam, and we asked ChatGPT to solve it. Right. The math and to be full disclosure, that we use the most advanced model. Right. We use the $200 per month subscription, and we used the most advanced model to solve it. But math, it solved all the problems. Right. Now this that's fine. Right. It solved the problem, but now we are building a tool where a complex problem, right, it will break it down into simpler problems. Let's say a physics question requires you to know 3 concepts, but then we look at this, we use an LLM to figure out what are simpler problems that if you knew how to solve, you would be able to put them together to solve this more complex problem. Right. So simplifying the problem step by step for a user, we are creating that. Of course, the tool is not ready yet, otherwise, and it's not for Python programming. But I just wanted to tell you about the power of these LLMs, how you can use it for learning, right? As long as you know what to learn, right? It can guide you in a very systematic way. And Python programming, I think it will nail it if you go about it that way.
Yeah, that makes some sense. Good. Thanks for that. Thanks for that answer there. I'll bring all 3 of us back up here. We've got a couple. I got one more, 2 more here. I'm going to give people a little bit of extra time since we had some issues here. There's one from LinkedIn. Doesn't focal loss benefit from this combined weighting and reannotation strategy? Can you comment, Paul?
You can absolutely use focal loss, but there are research. What? Oh, the cat.
I said bye, Zoe.
You can use focal loss, but that is in per batch, right? And if you have a huge class in difference, like 20 to 30x difference in classes, like ended up in Nexar Challenge, it is risky to weight the samples in the loss function and so on instead. So what we do is actually upsample. We provide more samples when data is loaded. We just, in Torch, you can use the weighted random sampler that will show that sample 5 times instead, which is a much safer approach to weighting data. And there is some good research papers around showing that is better.
Yeah.
Yeah, and we had a few. Any comments on this one, Satya, before we move on?
No, so it looks attractive. The focal loss looks attractive because, I think it looks attractive because again, you're using weighting instead of using the actual data. But if you use, if you upsample the data, you also have the advantage of augmenting it, for example, right? So there is more variation you can create by using this augmented data.
And focal loss has a tendency, if it's a big weight difference, to actually suddenly the neural network go haywire and there's no way back. So it's a little bit risky as well. I'm not a data scientist, but I played with this for many years now.
So you are a data scientist. It would have been it would have been much worse if you said that I'm a data scientist, but I've not played with this thing ever. Which
Just,
been in
a cave,
Yeah, there are people like that.
Sure. Yeah, it's from our trivia winner, OJ. Damn, I'll be sure to make the best out of this. Yeah, good. Congrats, OJ. We're sure that you will. I think we got time for one more question. Let me find it here. Yeah, someone, I think you may have answered this already, which was Pankaja in Zoom asked if the visualizations we were looking at earlier were based on TSNE clustering. Is that the case?
It was based on a UMAP variation called PackMap.
PackMap.
PackMap. It's more stable, we found, than UMAP that gives random results each time, even if you have the transform. You send the same vector through and it comes out a little bit different. So we chose PackMap to get consistency.
Cool.
But you can
in the tool. The progression is PCA people used to do, then TSNE, and now UMAP or its variants.
Yeah. So, but you can choose. You can use your own, or you can use the ones we have built in, which is also UMAP and so on. So it's up to you when you use the API. You define how you want it reduced.
Okay. I'm going to bring myself back and drop Satya off for a second. Yeah. Okay. Paul, so where can people find you on the internet here if they want to follow you on LinkedIn? You're on Blue Sky. Where are you?
LinkedIn is the easiest, and my email is paul@3lc.ai. Should be pretty straightforward. But I use LinkedIn a lot, so please contact me there. Yeah,
find Paul Endressen on LinkedIn. I think it's about time for us to hit the old dusty trail. Satya, you wanna say bye to the people out there?
Yeah, thank you, Paul. In fact, I wanted to do this episode a lot for myself because we spent about an hour at
we learned stuff
Summit, but I wanted to know more about the tool, and once I knew about it, I really wanted to share it with the audience. So excellent presentation. Thank you so much. And, we'll see you at CVPR, but we'll also see how, our audience can get more benefit out of it. We'll keep in touch. So excellent presentation. And thank you, Phil, for this, for organizing this. And of course, I really love this new tool, right? I think this is the way to go. We'll iron out the little technical problems, but this is way better than what we would do.
I think the quality overall is much better. I think we can. Hi, Zoe. I think we can set up the stream to be a little smoother next week. Thanks so much for everybody. We actually had very good numbers on YouTube this week. About 50 people watching live. Almost 100 people watching here on Zoom. So, yeah, we really do appreciate it, folks. I'll drop off Paul and Satya real quick here. Thanks for joining us, folks. We will be back. Not next Thursday because it is CVPR, but the week after we will be back with more learning, more computer vision, more artificial intelligence. Take care of yourselves out there and take care of somebody else if you can. Have a great day wherever you may be, and let's go Giants.